Okay, welcome everybody. This is our eighth meetup, and we're going to have a session seated by Alan Morrison on fair data. Alan has already given an overview, but we'll go ahead and get started, and hopefully the audience will pick up on the context. So let's go to it.
So like I was saying, Andrew, there are different approaches to data management that seem to reflect different attitudes about data. And data is very, as you know, is very disparate, and there are a lot of different things under the data umbrella. And some of them are perishable and single use only, and many of them are not perishable. So fair data that's findable, accessible, interoperable, and what's R stand for? Retrievable?
Reusable.
Reusable, that's the big one.
Uh-huh.
So I'm learning about this topic at the same time everybody else is. And I'm thinking that, okay, pharma's got a handle on this because pharma has to have a handle on it in some respects. And so they've got to collect a history of their studies of molecules, for example, and they have to be able to retrieve what they've learned over the years and reuse that to really build understanding around what they're trying to research. So I'm just thinking there's got to be use cases for other industries that drive that same behavior. And what's dominant now is the statistical mindset that's also machine learning, deep learning mindset that basically focuses on the task at hand, one project, let's get the data for the training set in shape for that one purpose. And no wonder we have narrow AI instead of generalizable AI. So for years now, I've been talking about symbolic AI plus the statistical AI, symbolic being knowledge representation. And so if I have a critique of data mesh, it's that we're not getting down and dirty with the data mesh. We've got a lot of framework and structure, but are we really hands-on with how we change the process? And I gave a talk last year that Greg may remember about how naval intelligence did it in the old analog days. And there were some lessons learned there. You know, you were focused on collecting and making use of and making reuse of the data that you were collecting. And so I don't think a lot of companies are really in the habit of rigorous data collection to begin with. So you start with the life cycle and then try to revisit that. And at the Semantic Arts talk a couple of weeks ago, I showed a diagram of an academic's redesign semantic data life cycle. I could try to bring that up. But anyway, that's the overview, Andrew. Am I rambling? Am I making sense? What does that set the stage for what we can talk about? Great.
Yeah, Alan, could you maybe give some definitions of your organic, inorganic split there?
Yes.
I'm hearing a couple of things, but I want to be sure I'm sort of understanding where you're slicing there.
Evergreen.
And evergreen as well would be good.
Yeah, so evergreen would be...
And evergreen, if I can add evergreen in relation to ontologies and taxonomies, or is it something else, or is it just that, or not even that? So those would be my questions.
And it's a good question. And I think all ontologies would be a given, that you'd be nurturing those and creating those as living beings, and trying to get those beings to grow in a way that's good for the ontology and good for the use case. So organic in that sense, I always think of living versus non-living. And so the living thing can be much more dynamic. It can be much more expansive and scalable. it also takes a lot of upfront work. And it's not just the T box, it's the A box, if you will, in an ontology. And it's not, it's the instance data as well, because if you're bothering to capture the instance data, then there is some likelihood that you might want to revisit it at some point. So you think of leaves of a tree, the instance data might be the leaves on the tree, and the rest of it would be the branches and the trunk. So that's the organic vision. And the inorganic vision is how you see people doing machine learning these days, which is basically stripping out all the context that was there to begin with, and then putting it back in a way that you think is suitable for the feature identification, et cetera. So does that make it clearer? Yeah.
Well, so you're just playing with the pile of leaves then in the learning. You're just looking at the leaves and trying to analyze their shape and color and whatever, and extract some meaning from patterns and a bunch of.
Or maybe you've got a wood chipper and you've put everything through the wood chipper, and now you're just trying to pick out pieces of wood and put them back together in a way that makes sense for your project.
Okay.
Yeah, and I think that in a way for machine learning, and many of the data scientists, I believe, in the corporate world are trying to answer questions that are already having an answer, but they need some data to support the point, which is a really bad way of actually using data. And I think that is very helpful to do the wood splitter part. Or what did you call it? The wood? The
wood chipper?
Yeah, wood chipper, exactly.
Yeah.
So doing it that way means you can have any outcome, but I think the context probably is important still, which is, I think, unfortunate, but I see it in many occasions in terms of the writing and how people see data science. And I think that is very much to undervalue all of the power that could come out of the discipline, having done it with actual question creation and actually answering some real important questions. But that's maybe a little bit of an aside, but I think it's
no, it's
too
a good
common.
point. It makes me think of a utility company example that I ran across while I was at PwC. And, you know, we were paying lip service to the fact that, you know, if you just capture the signal for the smart meter, and even certain aspects of the signal that are quote unquote noise can be useful in another context. So if you're just distilling and compressing, you're losing information there that maybe you ought to be capturing. And if you take a scientific point of view, we're supposed to be data scientists, you know, then there's lots of things you could do with data that you might be discarding as a matter of course.
Exactly.
I think the question that is risen here is maybe in the life cycle of data, and when you are considering deploying a data mesh, I would say the first maybe action you would do, or first steps, would be to organize things in a spatial way, okay, domains. And what we are talking about, I think, right now is so we are assuming that those domains are stable, and that's a good assumption, I guess. But regarding the next and future usages of data, that you will have a need to explore data, you will have a need to create new things, and typically that noise, okay, that is not useful for you in the first steps. Maybe in the near future, it will become useful for a new use case. And so we have a kind of deployment in time also, and that may be creating new data products, but maybe not only, okay? And I think this is really a tough question. And first thing, or at least to my experience, okay, the first thing, one of the first thing to do is really enabling this data exploration, which is another set of governance than maybe the one that you start with, okay, which is maybe really streamlined with your business. And so enabling that exploration with maybe new rules, and then you will have not only, it's not the same tree, okay, but you will have a kind of branches in time with your data products. And this, I guess, is really, really hard to manage.
I think to continue on that point, I think an important part of data mesh is to bring the data closer to the people that understands it and have the real day-to-day close to the data instead of having a team somewhere else that does the analysis. But that also demands a lot of people to really understand the statistics behind, really understand the necessary math and logic that goes with the data. So I think that in many companies that will be hard to scale up because I see that the statistical knowledge is in small pockets. It's far too small pockets, and it takes a lot of time to get into the details of how to think about statistics. I don't know if that is something that you see in a similar way, but that we need this data literacy in order to make it really fly and make it work. Or if that is...
I think the literacy would be great if we could achieve that, right? But it's sort of how do you get people and organizations to develop, I mean, that educational requirement. So I mean, are there alternatives to just waiting for everyone to sort of know what to do with the data or how to look at it statistically? And I'm really, of course, interested in models, you know, and going, so questions like, do we have the right model to marry the organic and the inorganic even? Like, are they both chemistry? Do we both see them as having something in common? Or are they modeled so differently that it's just really awkward to ever try to, you know, start putting your instance data, you know, into data mesh? Or, you know, how do those things touch, I guess, is the question. And I always sort of come at it from a model-based approach. Is there a way to fashion a shared model so that, you know, what we consider the hard raw data, the temporal data, and then the knowledge, you know, the ontologies, the sort of organized, curated data, they don't share the same model. I think that's the fundamental issue I see, and the fundamental solution is actually getting them on the same model. And I'm curious if other people see it that way, or you know, what people think about that sort of lack of a shared model for data.
Yes, I have been thinking about that a lot, especially the past few weeks. Absolutely. Yeah, that's why we have disconnects between what we see in application runtime and what's in a database and what's in a knowledge graph and what's in anything else. We have different ways to express or model data. I'll give you a simple example. We model APIs with Open API, which is just something sitting in a JSON file, pretty disparate from everything else. Now, when we want to interact with the database, it has its own model, so we have to map. So at least that's how I interpret what you're saying. We don't have a common model, therefore we can't link. Or if we did, it'd be something like, I guess, what Data Fabric tries to do. It'd be a few levels of indirection. But yeah.
Yeah, I mean, I think you're bringing up, you know, there's the table of the relational database. There is the tree essentially of JSON, XML. A lot of the serialization formats are sort of hierarchical in their structure. And then we have, you know, full out graphs in our ontologies, and, you know, sort of our knowledge is best as a graph, not as a table. You know, facts we can find as tables, and that's maybe some of the evergreen data Alan's talking about. Is just a list of area codes or zip codes or something like that. You know, that's evergreen data. It's just table, right? That's helpful. It doesn't need to be fashioned into sentences or made semantic in any way. But it would be helpful if you had a model that said, hey, you know, I've got I'm training on some corpus of natural language, and you know, I want to analyze that, and what I'm getting out are either sort of you know, identified words, concepts, with or without sort of their graphical structure, right? Are they still connected semantically Or do we just get a pile of leaves like Alan was talking about? We have to somehow reassemble or
Right.
count the instances of words and then sort of try to derive some meaning from their association with which leaf they're next to, right? I mean, that's essentially what I see large language models doing, is just taking a pile of leaves, trying to run an analysis, statistical analysis on that, and then sort of recover all the meaning that at one time was in that data before we put it through the wood chipper, right? But we never had a model to actually capture it in that native state. So I mean, I think it's about organizations that want to create data, capture their domain knowledge, but do that in a model that's actually extendable into the operational data.
Yeah.
As you said, the temporal aspects, as you start to sort of collect data about these ideas or concepts, but that all needs to stay integrated. You can't put it through the wood chipper and expect to sort of out the other side, come truth, come certainty, come knowledge. I mean, you'll get statistical information, which is useful, right? But it's not going to be the hard sort of knowledge that I think people need for decision making. Is what do we know, and do we have a model for that? So that's a lot all over the place, but I'm sort of speaking to what it would need to look like actually to bring all that together.
Those are helpful points.
I came to, if I try to take some of those parts and just take the next step on what you were saying, I come to a little bit that we are ontologizing and bringing all of that structure together for our data in our enterprise to various degrees. But in order for the models that are usually developed outside of our enterprises, sometimes they're developed within, but we would more or less be able to attest that these data points conform to a common vocabulary that is useful by the models. So that we're able to have standardized ways of using our algorithms and models based on specific shapes of data, based on specific values and formats for everything, so that we have ways to reuse our models and do and our ontologies become linked between these two. So more or less to link the concepts between our ontology and between the organic and the inorganic world in a way, to have those scaffoldings and to have that as an expectation. I don't know where I'm going exactly, but I'm philosophizing around how that might look.
I think that is the approach. It's essentially the schema, right? Fashion a schema for your domain and then try to tie everything back to that, right? Which might look like an ontology, or might look on the data side more just like a schema. You know what the fields are in your data, you know where they're going to link to your ontology concepts.
Yeah, I see it as, I don't know, maybe not. So I'm seeing it not only as the links between them, but actually as the expression of what they really are. So that if the two people are looking at it between two organizations, they would be able to recognize the two concepts, meaning that the ontology becomes explainable in a way, in a more standardized way, like we have with ISO for different units of measures and similar, so that we have those in a way that is more standard in how we express the data.
Yeah, and I don't know, Philippe, if you've read Mark Wharton's critique of APIs, and Andrew was mentioning one of the shortfalls of APIs, and so what you seem to be driving at is more of a self-describing, designed to be immediately interoperable kind of model. And there could be other model types that it could connect to if it had the same connecting characteristics.
Yeah, it's a metadata.
Yeah, so it's the metadata, and the metadata has to be a lot richer. And in our personal knowledge graph working group, we have Margaret Warren, who's specifically focused on images. And she just wants to get the basic metadata back because Google strips it out in a lot of cases. And so if you've got valuable photos that need to be referred to again and again, it makes no sense to do what they're doing with the metadata.
I like this no API approach, or at least putting it in the background. From my perspective, my point of view, is something I've been thinking about for some time, is that at least the biggest industry of all in tech is software engineering, and that has created this mindset that the code should be the interaction and it is behavior. But I think if we started with schema, metadata, and that's how people quote unquote programmed, they looked at the data and they manipulated it. And as a result, there was a reactive process. There's some logic baked in behind the scenes that would, be invoked. That would make it simpler for people to, at the how should I say it, at the layman's level, be able to interact with it. I'll give you an example. Microsoft Excel spreadsheets, people hate it, at least tech people do, but regular people like it. Why? Because they can start typing, they can start putting values in. Is there logic in there? Yes, but it's like a reactive logic. It's behind the scenes, and you can go in and you can add behavior to it. I see something the same for being an ontology builder, right? So you can create new ontologies and start putting those out there that can be linked when you start having two organizations that start interacting with one another, but that there's logic that is threaded behind the scenes instead of putting it up front. If you think of the reverse of a object-oriented program where you deal with accessor methods, in this way, you're dealing with just the data with a logic behind the scenes. When you start looking at the code, you're looking at a graph. You're not looking at code. The code's there, but it's secondary. In the same way that if I am interacting with someone else, if I go up to my dog and pet him, that's the interaction. He may respond. I don't see his response. I just know that he does that, right? And maybe it sounds like I'm smoking crack a little bit, but that's how I see it. Yeah.
I really like the approach, and
You're putting ontology up front. Yeah.
Yeah, what comes to my mind is basically an ontology for the transformation of the data. So it's kind of a different angle. If I see where you're going, that is the inference of the basic data. So you code the inferences like you do in Excel. You inference more or less new values based on data, but you would do that at scale with the ontology, with instances in the ontology. So you can do transformations automatically and see what you have in a graph or what you have in your data set in a different way. So basically the pipeline, but not crunching, but having an expression rather than crunching it and doing it through software. So like an inference engine or something like that. Am I following a little bit on
Yeah,
what it is that you see?
I think so. And imagine what the industries that we have now, how they would dissolve and go away. For instance, I'll pick on one. We have this whole industry now called observational, what's it called? Observational observability data, right? And that's all about determining the internal state of a system or a piece of software or something. And so what they do is they look at systems and try to figure out or try to instrument how they're operating to get some insight as to what's going on. Well, if people were coding in ontologies, say, for instance, that's how they expressed their data and behavior and everything else. If I wanted to know that a certain data construct changed, I would just react to it. I would be a listener to that change, and then I would be able to do anything I wanted to. And there is no mess of trying to go into somebody's code and trying to figure out, how do I get at that? How do I expose this behavior? How do I expose this event that occurs when the data construct is in the front and the logic is behind? I mean, this is not necessarily new, and it's worked actually amazingly well in Excel, but it hasn't been done for enterprise or for worldwide consumption, that, to my knowledge, at least, we start with behavior and go back and we hide the data structures. And knowledge graph people, I think, do think differently, but there's no behavior threading that I can see in knowledge graphs.
Right, and I think the only example I've seen of that, Andrew, where the behavior is explicit and out front is the event-driven knowledge graphs. So somebody who's quite willing to talk on this topic is Jans Osman of Franz, and he's the Allegra Graph database supplier, one of the triple stores. Actually, it's a quad store, but most of them are quad stores.
Interesting. And
Yeah.
Alan, you talked about living data. If you gave behavior to ontologies, would that not be living data? In other words, the graph grew as you interacted with it.
You just delivered an insight. I hadn't thought about that. Yes, it's behavior is often what distinguishes one thing from another. And so you've got these characteristics that you need in play if you're going to interoperate. And so absolutely, I think we ought to be behavioral scientists in a way, shouldn't we?
I've heard that before.
Especially in business.
Yeah.
And to just clarify, when we speak of behavior, are we speaking of sort of the programmatic, the coding aspect where data is actually being programmed into some application, or are we talking about human behavior or sort of, you know, end user behavior? I just want to put a point on what this behavior is, because it sounds metaphorical, and I want to make sure I'm putting the right metaphor.
Andrew can jump in on this, and I don't want to talk for him. When I was thinking about behavior, I was thinking about process. And so when Jens Osman talks about event-driven knowledge graphs, it's about process design and capturing the process that's in place and then evolving the process. So there's this whole category of software that most of us are familiar with that has tried to do that, but they haven't gotten close enough to really be successful at it. And it's because they're not in this data mesh, data graph environment where humans are trying to pull things together and make them work better and optimize them. So you can see how optimizing the process would just jump to mind, Andrew. Were you thinking of something else?
I'm not sure. I was thinking of the former modeling the latter, which some would interpret as a digital twin. But sometimes some things that you model don't exist in the physical world. And in that case, it just lives virtually. Right.
Right.
Yeah.
So in the case of monitoring emissions at Portsmouth International Port, you've got sensors and then digital twins at each sensor. And then you've still got a host, Greg, and it's monitoring the behavior at the port that leads to greater emissions. And so if a particular ship comes into a particular berthing at a particular time, then you want to be able to share out that ship is really contributing a lot to the emissions footprint.
Yeah, makes sense. I kind of want to circle back to Olivier's original conversation real quick, and maybe this is related, but I'm sure we'll find a way to tie it in. He was talking about federated learning and that it's, you know, to deploy it, to construct that, there's a lot of nuts and bolts to that, and it's just very difficult. And I remember when I was part of another group, we had a guest from Intel that was having these same issues with federated learning. And he had a few good articles, but I'll point you guys to them after the call. But he was talking about the US Navy had very large data sets and they simply could not move. The data gravity was tremendous. And plus they didn't want to share the data. So he said, you know, it would be great if the system, you didn't have to tell the system to federate, it just knew. So based on the logic in the system, it would know implicitly to move the logic to the data because of gravity, because of sensitivity, because of any number of factors. And I don't have to tell it that. It was just very declarative. I want this answer, and it knows whether to federate or not. Maybe it doesn't need to federate based on the logic that's baked into the data models present. And I thought that was just that he's not saying how to do it, but his ask was very fascinating. Like, why can't we do that? Why can't we just say, I want to learn something. Here's what I'm looking for. And the system figures out whether to federate, whether to not, whether or not to provide you that data, all those concerns that we have to deal with every time we encounter a new system, the underlying substrate deals with that for you automatically. That enables cross-organizational collaboration without pain.
Mhm.
Because governance is baked in, the constraints of technology are baked in. You don't want to move a large data set or, things like that. Anyway.
Yeah, this is generally at least the case we have been discussing previously. It's really the motivation is not moving data, as you explained, because sometimes it's hard. But the counterpart, okay, and the other side of the coin is that you need to govern also the learning, okay? So just previously we were talking about maybe this code and data duality, and this is another example, okay? Because you always, if you're part of a federated learning approach, and you provide data, you keep your data, but then you will have to host in a way and to trust pieces of codes, okay, packages that will do machine learning on your data, that will produce a kind of learning increment, okay, and then federated learning is a way to add all those learning increments together to learn something bigger. So it's very attractive in a way. Okay, it can create new problems for sure, but this changing, and yeah, it requires you to think with this two-dimensional view, code on one side, data on one side, and then also the learning code. Okay, and this is to govern learning code. I think it's also quite hard, maybe harder than sometimes move data.
I'm super curious to go down a little bit in this one. So absolutely, I'm thinking more or less what we have are two things at least that I'm thinking of, and one is that we would need to capture all of the inferences that are valid and also the ones that are invalid of what we can do with each data point that is there. So that when we want to ask questions, we would need to understand what is valid to do with this data point. So what can we extract for meaning out of it? But also then package the computational aspects of it, of what we can get out. So it basically becomes the black boxes, and those parts are probably the easier ones. But then capturing the rules for the individual parts of the systems that can be put together as building blocks towards automatically in answering questions are some of the things that I kind of derive. I don't know if, Olivier, I'm free spinning here, but.
I mean,
I'm not sure.
I get what you mean. Go ahead, Olivier.
Go on.
No, I was thinking, I think you get what you mean, and the way I talk about it is like, basically, we're bringing compilers to data sets because we've also included data. So there's elements of that in knowledge graphs, like for instance, Shackle and stuff like that, but you're basically compiling this triad of logic and data and everything else. And in your compiler is what, every different consumer has for a set of rules. Anyway, that's how I see it. Is that an adequate explanation based on your perspective? Like, it
Another
doesn't
way
matter
maybe
whether
to see this in a conceptual point of view would be to consider these learning increments. Okay, they are kind of parts of machine learning models, and we would consider them as data, okay, or at least something that we can share between organizations. And we are back maybe to this patterns conversation we had in the past. When you use an API, okay, what is shared is you share your request and then the result is shared, okay, in a kind of maybe remote procedure call or basic thing, okay? And request and result can be data for sure, or are always data maybe. And if you consider another basic pattern, which is only data sharing or pure data sharing, you have the data attached really as a product, attached with metadata, all the meaning. So it could be knowledge and ontologies, whatever, okay? But there is really moving data, okay? The action is moving data between organizations. And I've just described two flavors, okay, maybe of collaboration, but there are multiple ones, and federated learning is an alternative to this, to by creating this learning increment. So introducing a new kind maybe of data, which is not the original data you learn from, okay, so maybe from a privacy perspective, it's better. But it's cutting things, okay, so it fits your collaboration scheme. I have an example of different collaboration schemes, because the basic example is we do federated learning because there is a lot of data scattered in multiple organizations, and another organization have to learn from all of them. And it depends on also the willingness of every organization to share the data among themselves. Typically in the automotive industry, you have sensors in cars. And if you consider multiple brands and maybe on multiple areas in the world, you could create a map out of this. And this map is a new data product, but it can only, it will be, the quality of the map will be better if you have multiple, like crowdsourcing, okay, data from different organizations, and maybe also the quality would come for overlaps. And I'm quite sure that different brands, different car makers will not agree to put all their data all together in the same place, and also in the same format or representation, or even same meaning. So yeah, it's very complex, this cross-organizational collaboration in some cases.
Yeah.
And it makes me think, Olivier, of knowledge management versus learning management, and how there are different departments for data management, content management, knowledge management, learning management. But really, there's a certain amount of data that has to be shared regardless of the immediate purpose. And so can't we just have one method of federation for all of it?
Yeah, as a software engineering background, I'll give you my perspective on that. Why do we have, I have it here on my board, why do we have API catalogs, data catalogs, databases, files, container registries? Why do we have all those things when they're only useful when you put them all together? Why don't we implicitly put them all together? Is that what you're driving at? You're talking about different disciplines, and that's the more that's like the background to that, Alan. But is that close to what you're saying?
Oh yeah, I think you're taking it from a software developer engineer's perspective, and
you're talking about disciplines, but really they're interrelated in a sense.
Yeah, I'm talking about organizational behavior and how to restructure the organization. One of my other hobby horses is, how's the organization going to change when we have organic data? And so one of the frustrating things is that it's hard to make any progress at all in a sort of a brownfield environment. It's better if you've got a greenfield environment to start with. And you can just basically set up the organization that you want the way you want to set it up. But I haven't come across many great examples of that.
I'm hearing something reminds me of my recent shopping for my wife for skis. So we were trying to compare different manufacturers' skis, and this is to what Olivia was saying about the auto manufacturers. And I guess what I'm getting at is it seems like there are business reasons why data is not interoperable, and they will not go away once you solve the statistics or the data model or anything like that. And it was this, I wanted to find out, the turning radius on a Solomon ski. How does that compare to turning radius on a Rossignol ski, right? Well, they may use different statistics. They don't use the same standard, or if they do, like I want to know which was the heavier ski, right? And so one company weighs their average length of ski, and then that's what they report. The other one, reports out each weight of each length of ski, which is different within a certain line, So the problem was there was no standardization of how they present the data, right? They all knew, I'm sure, how much their skis weigh and what the turning radiuses were and what the widths were at the waist and the tip and all this is known, but there's no incentive for the industry to report this in a transparent way, right? So it's not fair data because no one wants it to be fair. They want to sort of highlight the feature that they are most selling skis off of and obscure the sort of shortcoming compared to their competitor that, this ski is a little heavier, but it turns better, right? So, I mean, it's sort of by marketing and design, right? That they all handle the same data differently to make different points, right? And I wonder how much, banging heads against the wall there is about expecting things to be transparent and comparing apples to apples when no one wants, these guys want to sell apples and those guys want to sell oranges, right? And that's just the way it wants to go. So I don't know if that's what I was hearing, Olivia, when you're talking about the auto industry, maybe just not wanting to have a fair head-to-head comparison of their, models, features, products, parts, whatever. There's good business reasons not to have everything sort of transparent and obvious when it comes to data presentation.
One thing that I derive, and I also think about the personal knowledge graph community there, and kind of what I see there is perhaps the ability to have kind of an Excel, but that is constraint based instead. So you put in your data, you put in your necessary constraint, and you just let it play. So you just have an expert system immediately available for almost anything. You just put it in there, and you would be able to scale that in the organization. So you start on your desktop, you put in the necessary constraint, and you can build a small building block. That would be the learning, and then you feed that into the organization, and you bring all of those constraints into the organization. So you, instead of having procedural software, you have deducting software, like the products of the world that kind of only see them in very limited spaces, not in general use for many of these things. So I'm thinking that of your problem to select skis, it's more or less you have a few parameters and you're selecting kind of a midpoint and you get what you want out of that. And I think that in many business scenarios, that would be a very interesting thing to have, but at scale.
I think the most useful tool for this problem would be something like Microsoft Excel, because I can just take the data, right, from all these different labels on skis, put them into one spreadsheet, and I create then a schema for, this is a column for weight, this is turning radius, this is length. And then I do the analysis because I have sort of created a format in which all the data now is interoperable, right? So how do you do that at scale, right? How do you just abstract everything back into the spreadsheet, right? If that's what you want to use, without having to manually do that, right? Like, because we want to just be able to go automatically, have this data come into that new format where we can do analysis.
Yeah, and leave and be able to leverage what everyone else did as well, so that it's easy to share these models with one another. So it's that Excel becomes interoperable with someone else's in an easy way. So all of these become small knowledge building blocks or nuggets of knowledge around the data.
Yeah, I've been struggling with this issue at a company I had a contract with, and lots of Excel. Really sort of hand-built assembly, very, very customized equipment that they were building. And they had spreadsheets out at the wazoo in each department, and even sharing between departments was problematic. And so, Cambridge Semantics, when they started, their goal was, let's eliminate this spreadsheet hell, or at least alleviate the problems with it. So the the platform that they envisioned was directly targeted to that purpose. Now, after they were in business for a while, they drifted away from that, probably for good reason, because it's such a hard problem to solve. And I'm thinking the other aspect of this that might not be evident at a high level is that in a learning environment, you've got very different tiers of abstraction. And you have to think about each tier of abstraction related to another equivalent tier of abstraction. And so at a very concrete level, you've got the base information that could be processed by a human and made into information or knowledge. But how do you automate that process? So in the personal knowledge graph working group, Yuri is working with academic papers and just annotating them as he sees fit, and just to get it out there, just to get the stuff out there to work with. And it's an open data environment. So academia would be an example, Greg, of place where they want to share. They want to know what others are doing so they don't reinvent the wheel. And there are other open data environments that we could try to attack or explore. But you're, you know, there were so many obstacles to even trying to get to the first base from an organizational standpoint and what I was trying to do.
What Greg brought up with his example was essentially exactly what Eric Broda's article that Philippe and I had contributed to talked about, which is making, I call it the darkening of derivative data. So for example, Greg, yeah, and it's a problem because that's what keeps people from building on public data sets, where it stops right there in its tracks. Because if Greg was able to take the vendor's data, and right, they're not responsible for lining up the same units. That would be some standardization that's not, it's not in their interest. Why would they spend time doing that? They have units that they want to declare, and so be it. But if he created a derivative work that did the transformation of those units easily, then did the comparisons that he wanted, and he was able to publish that, and someone else could discover that, say, looking at skis and say, oh, somebody else out here created links to these data sites, and they have this, you know, this logic they implemented to be able to get a fair comparison of these skis for this reason. So if people, going back to personal knowledge graphs, were able to make their derivative works discoverable, that's where you get that synergy from publicly available data. For instance, that would have been awesome if we could easily have done that in COVID. They did it despite the fact that it wasn't as easy. But if we are able to do those sorts of things, that would be great.
It's a good thought to capture. I hadn't thought about it that way.
The other thing I would highlight is when I talk about, you know, the importance of the model, it's not just sort of, you know, knowledge graphs and tree data and tables. It's also, I mean, what makes Excel special are the calculations, right? It has mathematical functions in there. And so the model actually needs to be mathematical also. You actually need to have a standard representation of, and from the math, you extend that into the coding logic as well, which sounds, you know, like a big jump. But I think that's what we're getting at, is we need this sort of universal language that can speak both the structure of the information and what we do with it, that whether it's the behavior or the coding, or we actually need a language to speak all of those things at once. If you're going to take something like what everyone does in their Excel spreadsheets in every department and somehow abstract that into useful information, you actually need to abstract both the tables and the formulas, the calculations they perform over those tables. It's not useful to have one or the other, because you're just recreating the wheel to pull all those numbers together and then do some more crunching on them, right? So you need to know how people are crunching their data. So which means you need the logic, you need the mathematics that goes along with the data, and that needs to be in the same model, in my opinion. And, you know, obviously pattern logic, pattern is my approach to sort of abstracting all of that into one model. But
yeah,
just highlight, it's not enough just to get the data. You need the data with the code, with the logic, with the mathematics.
And those associations expressed exactly. And a lot of data is derivative data. It's data produced through pushing raw data into some logic and producing other data sets. So if you had that, what you described, Greg, you're implicitly creating lineage, which creates trust, which is helpful.
Right, exactly.
When people talk to each other.
Exactly. And Greg, when you were talking, I was thinking about algebraics, which was a language of algebra that was designed to be universal in those kinds of applications that you were describing. And the problem with algebraics was that the people who were interested in it, there's a very small group of people. So, you know, I think they might have really made some inroads on the problem, but just trying to sell the product was just impossible.
Yeah, this is not a new problem. I think it was Gottlieb Leibniz was actually working. This is one of the things that really drove him, was this you know, universal language, right? That we needed a symbolic way to represent. He was focused on logic, but I think the problem still stands. That there's a great promise for that, but still, it's a dream in many respects still.
It seems easy sometimes to distinguish code and data, but when you, if you open an Excel sheet, if you have one Excel sheet, some people will say it's data, because they care about the data when they open the Excel sheet. But some other people would say, no, it's code, because what's important are the formulas.
Mhm.
And honestly, it's been a kind of obsession, personal obsession in the last 15 years also. What is code and what is data? And I don't have the answer. I think really it depends. And I would even say, and it reminds me of a quote or a story from the first guy in quantum physics. I think it was Wolfgang Pauli and he said something, if I put a hand on my left eye, I see a particle. And if I put a hand of my right eye, I see a wave, between the particle and wave duality. And personally, I consider that and when he opened both eyes, he will go mad, And I feel quite the same with code and data.
Perfect.
And
that is
that would
perfect.
be my answer to Andrew, saying, sometimes it's an API, sometimes it's data, and we don't know. The reality is that it can change.
That is, yes. And isn't it true that it can change in quantum physics depending on intention?
It depends
On the observer.
It depends on your model, of the reality.
Yes.
And I think the reality is that you need both. That neither one is adequate alone, and you can't have code without data. It's worthless. You can't have data without code. You don't do anything with it, right? So it's not that I see why you struggle with that existential issue of code versus data. But the fact is that people like the marriage of the two. That's why we still have spreadsheets, right? That's why people still use them, is because it gives you this environment in which you can create the data and you can manipulate it, right? And to do both is actually what we want. So it's not a matter of like needing to clearly define and separate them. It's actually, the problem is how do you actually see them together? How do you actually use both eyes, right? Because one eye is not enough to understand really what's going on.
And continuing the quantum analogy, they are always entangled.
Yes.
I mean, you're laughing, but there's some truth there,
Yeah.
Yeah. I mean, that's an excellent analogy.
Yeah.
I was just going to say that people hate spreadsheets, but I think Greg put a dot on that, in that, what's great about it is that it encapsulates the code and the data. Everything is into one workbook file. Everything's the portable unit, and people like that.
I would probably
that's
phrase
the
it
model
differently.
I mean, I think that's what you need to achieve, is something that is, user-friendly in terms of creating code calculation, and user-friendly in terms of import-export of data, and nothing's better than a spreadsheet right now in terms of the average user, right?
I think the right way to express it is that we all want to hate Excel, but we love it because it is so easy to just do something when necessary. And in a way, we hate it because we're always making some first attempts at it. We know it's not the right thing, but it's good enough. And I think that is a large portion, at least for me, in this love-hate relationships with Excel or spreadsheets in general, because it's so easy to get started. Every other thing is harder. So we always start there, and then we create some monster, and then we realize we need to do something good with it.
It's the same thing, okay, for different, it's the same thing for data science Python notebooks, okay? It's both code and data, either what you want to look inside, okay? It's the same thing for infrastructure as code, okay? It's a YAML file, okay? So it's data, but when you use it, okay, it creates API calls in the cloud to provision infrastructure. So is it a data, is it information, or is it something, is it an action? It depends, okay? And it also depends in the life cycle of the thing, and it depends on the tier, okay, the layer you consider, okay? Alan just earlier mentioned these stacked layers, okay? The landscape currently is tremendously complex, okay? And you are always working with a slight, very thin layer, okay? Because nobody can embrace the whole thing from in data management or IT, whatever.
And just to draw that analogy even further, I think what we're talking about is partly the difference between machine learning, a statistical approach, which is, I would say, the entirely code-based approach, right? I mean, it has data, but it's really about the model and the calculations that you're doing over that data, and that's how you draw your conclusions. Versus the semantic web is actually I see it as the data side of this, right? It's sort of like, let's nail down the facts in a model, right? But it's not very good at calculation, right? It's harder to calculate over that, which is statistical model is pure calculation, right? So it's, again, the marriage of the two that we actually want. We want to bring the sort of facts of data together with the ability to manipulate and code and calculate over that. But they're different models, right? And that's what's hard. They're both graphs. We're getting closer, right? In some sense, you can think of them as a graph encompassing either, but we need the same kind of graph, right? The graph that can both calculate and represent truth. And I think we're heading there, but that seems to be the marriage again. The killer app for graph, the analogy I use is always go back to VisiCalc or the initial spreadsheet, right? That was the killer app for personal computing. The killer app for graph computing is going to look the same. I think it's going to bring together the code and the data in one sort of common man user experience.
An interesting area. Going back to where we started, Alan, I was thinking of how you saw pharma and other locations where these ways of working are really important. And I see another one that is very much emerging. And I've been working with Zero Trust and dynamic policy engines that should be able to take facts. And I'm thinking back to what you're saying there, Andrew, as well. And I'm thinking a lot about how to make those automated decisions at scale automatically. And I'm thinking that involves machine learning, that involves making good enough access control decisions that we can trust, that are good and that are really good enough. So that will need us to really have these abilities to express derivatives of data. So really this code and data approach together for making access control decisions in all of the softwares in a few years' time. So it'll be interesting to see how that develops, because I think a lot of what we're doing in the knowledge graph with machine learning, with other things, will come together in cybersecurity to something quite interesting, where we need to model things correctly, we need to make decisions on that data, and we need to make it accurate at the same time.
Yeah.
So is the focus, I mean, access control seemed to be a component of this, Philippe, but is that one of the key factors for you? Can you sort of explain why?
Yeah, so what happens is that if you want to make an access control decision on dynamic data, you need to control your data. You need to make the decisions based on that, and you need to really have that tree of calculation that comes down to an ultimate decision. Is this allowed or is it not allowed? And when you have all of that data that is moving in the world, you need to have a way to capture how you derive an access control decision from them, but at scale. And that would be, in the easy instance, it would be very few calculations. So you have attribute-based access control. You have some attribute that changes and that gives you access or not. But we need to derive that from a whole environment, whether the user is trusted at the moment. How do you work with that? How do you derive that the user has the necessary parameters in the ecosystem to a good enough extent to actually allow them through the system? I think those kinds of massive graphs that needs to be up to date in the instance and making calculations on them might have some of these properties as well.
Mm-hmm.
How is the decision logic modeled for that permissioning?
It's emerging.
Someone's hard coding it, or
I mean, today it's mostly, so there are role-based access control systems. You have attribute access control systems that make calls to check somewhere whether a few parameters are good or not. And as that model becomes more and more granular, you have more and more parameters to look at. And so you need to make access control in the moment in some software that tells you whether that access is okay or not. So if we look at the Department of Defense Zero Trust architecture, we have NIST Zero Trust reference architectures. These are the things that they describe there in terms of how to make these policy engines work. But they're not 100% on detail because they see that, well, the industry is not there yet. We are seeing that the first policy engines, maybe in some specialized cases, start to exist. But they expect that this will be in a 2-3 years time that these will really emerge in a good way. There are some open source softwares, the Open Policy Agent that has some of the languages around this that are interesting to check, because those are really expert systems that you can code decision derivation trees from. I don't know if it answers, but yeah, it's a big space.
It used to be just like you had the password or you didn't, right? And the username and password, and it seems like maybe security is moving towards a little more nuanced approach where it's you know, that password's good enough, or that two-factor authentication is too old, or or correct, or so. I mean, it seems like there is a lot more decision logic going into those systems. But are they still just purely deterministic, like user password correct or not, or is it there's actually decisions that are more subtle than that?
They are deterministic in a sense. They would have a rule set that they abide to, but it would not be only the authorization or only the authentication. It would be the authorization part. Do we allow access based on the current risk setting for this environment at this point in time, based on real world events or what have you? And so suddenly you need to make an assumption about the world and what it looks like, and make a decision based on that. And that needs to be automatic. So, I mean, no one will sit there and make the decision for you. You need to automate all that decision making.
Yeah.
So it's still deterministic. It's just getting more complex. It sounds like.
Very.
That's interesting. I kind of wish that access management was more like paywalls on the internet. And I'll try to describe what I mean by that. So if I'm looking at investigating a topic, I may get some articles that come back from Google. Some are free, some are not. And I have enough information to know that they're relevant to my topic. So I'll go to the Washington Post and New York Times. And once I get there, I can read the first paragraph or two, but then it wants me to pay. But if access management was more like that, let's just say I could ask a question because I'm doing research. I asked to ChatGPT. ChatGPT takes advantage of this super graph or large graphs or something, and it finds information for me. And so then we have this lazy access management that says, I found the information for you. Here's the publicly available information. There's other information available, but you need to have some kind of access to it. So it presents you the access management when you need it. You didn't know you needed it. So imagine the way we do things now in the enterprise. You have to upfront get access to all those systems before you even know what questions you want to ask. Whereas in access, yeah,
I think that is where we're heading.
That's awesome.
So I think that is, if we're doing it well, that is where we're heading, because what we would do is to actually augment the necessary authorization based on circumstances, so that if you're, for instance, like you have in Google as an example, so if you want to update your password, you need to provide your multi-factor. But if you don't, well, it will let you do most things without actually providing additional checks and balances. But I think that will be much more pervasive in our environment, so that whatever we're doing, it will be checked against, is it reasonable? And we will encode this reasonableness of a request based on a number of things. So that authorization, sometimes you get access, sometimes you don't. It depends really on your history, it depends on everything. It becomes, the worst part of it becomes a little bit of this Chinese surveillance systems and a social score. That is the part that I have the hardest part of ingesting relating to Zero Trust, because it is really, how has this identity behaved in the enterprise during the last 24 hours, more or less? I mean, if we're trying to log into 100 systems and we get denied on 99% of them, probably we're trying to do a bad thing. But how nuanced will that be when we're starting to get to the nitty-gritty details and these models become quite fine-tuned? I don't know. These are some hard questions that the entire cybersecurity community will need to answer.
Very interesting problems for sure.
Yeah. And that is what I was at the beginning of the call. I was deep down into this and just, wow, what time is it?
Perfect. So it looks like we're about, well, we officially allocate an hour. It's about 15 minutes past that. I'm okay with that. Is there anything else that we want to do before we beat this horse to death for this call? I'm okay to stick around a little longer, but if we think our brains are fried for now, we can call it a day.
Yeah, I think my brain was fried quite a while ago, but that's what I wanted when I came to this call. So thanks so much for it.
That's the goal.
Yeah.
Thanks, everyone.
Your brain is
Appreciate it a lot. Brain's fried here too.
And it's end of day for you, so yeah, you're toast.
Yeah.
I have to go recover for a bit before I get started with my day.
Yeah.
See you later.
Good to be
Okay.
here.
Thanks a lot for today. Take care, everyone.
Bye-bye.
Bye.
Thanks.